Basic Skills 5, completing the square. So we could put the quadratic in vertex form. It's pretty tricky, but the steps remain pretty consistent. So we always want to start this off by pushing. Let's say we want to remove this and set this equal to 0. So we always want to start this off by moving whatever C value is to the other side. So we're going to subtract 69 on both sides first. So what we are going to start with is 2x squared plus 24x. We have this space here now, right, where that 69 was, equals negative 69. Okay. Next, we want to check to see if we have a common factor on the left-hand side, and we do. We have a 2 here. Because we want to put this in vertex form, so we are going to need to pull that 2 out. That's x squared plus 12x. We still have this space here where we need to make this a perfect square trinomial. Right? Perfect square trinomial, that's how we get vertex form. So now, in order to fill this line, so again, if we're going to add something to this left-hand side, we got to make sure that we're adding it to the right-hand side as well. We're adding something to the left-hand side, we got to make sure we're adding it to the right-hand side as well. So now let's figure out what we're going to add to both of these sides. So we want to make this a perfect square trinomial. In order to do that, we got to take this 12, divide it by 2, which gives us 6. And then we are going to square it, which gives us 36. So we're going to add 36 here. Okay. And this is the part that a lot of students get incorrect, is that when we're adding 36 on this left-hand side here, that 36 is actually being multiplied by 2, right? Everything inside that parentheses is multiplied by 2. Just like this 12 was 24, right? Is being multiplied by 2. So it's the same value that we have up there. We just need to make sure that we keep consistent. That 36 is also multiplied by 2. So on the right-hand side, right? So left-hand side, we added a total of 36 times 2, which is 72. So on the right-hand side here, we have to add 72. All right, and that's because this was multiplied. I'll leave that there so there's no confusion. So now simplifying this out, we know that this is a perfect square trinomial here, right? So it multiplies up to 36 and adds to 12. That's 6 and 6. So this simplifies down to x plus 6 squared equals, on the right hand side, negative 69 plus 72 gives us 3. And then finally, subtract 3 back onto the other side. And we have our answer. We'll have 2 times x plus 6 squared minus 3. And then equals our original, what's this? Equals y. We could put y here, we could put y at the end, whichever. There it is, vertex form. Okay, number 2. We're going to use that information to write the vertex form of the equation of each parabola. So vertex form, I'm hoping you guys are pretty familiar with the form by now. A times x minus h plus k. Okay, and we're going to plug in through here. So we know the vertex is h comma k, and we know the point that it passes through, that's going to be x and y. So we're going to plug all those into here. So we have a y, we have an x, we have an h, and we have a k. We're going to plug all those in there. So x and y were in blue, h and k were in red, just to keep consistency. So let's start plugging in. So we know y equals 11. So 11 equals a. So a is the one value that we don't know. That's what we're going to be simplifying for. Times x, which is -1, minus h, which is -3, squared, plus k, which is 3. Okay, PEMDAS, we got to do inside the parentheses first. This turns into a positive. -1 plus 3 gives us 2. 2 squared is 4. Here, I'll write that step out. 11 equals a times, right, -1 plus 3 turns into 2. Hopefully that makes it a little easier to see. So parentheses are taken care of. Next we do exponents. 2 squared, that gives us 4. And we can also do this 4 times a, which gives us 4a. So 11 equals 4a plus 3. Okay, now we're going to start solving, so we're subtracting 3. So this is 8 equals 4a. And then finally divide by 4 on both sides. And you get that, let me move this up here. 8 equals 4a. Divide by 4, and you get a equals 2. Okay. So we haven't written the vertex form equation yet, but we have the a, which is what we need. So what we're going to plug in is the h and the k. We're not concerned about the y, so y equals a, which is 2. We just found that here. Times x minus h, which was -3, plus k, which was 3. So the x and y stay unplugged. The h and k we plugged in for. And then last thing we got to do is simplify this here, because that's a double negative. So our answer should be y equals 2 times x plus 3 squared plus 3. And we go ahead and box that out. And it's pretty simple to check if some of the information is correct. Right? We know we can tell the vertex is the opposite of this, which is -3, and this, which is 3. That's our vertex there. The problem gave us our vertex. It matches up. Okay, number 3, solve each equation by taking the square roots of both sides. So we got b squared equals 49. To undo a square, we got to square root both sides. So if we square root both sides, we know that squares and square roots cancel out. So we're left with b equals plus or minus 7. 49 just happens to be a perfect square. Number 4, we got -5r squared equals -40. So start off, we got to isolate the r. Divide by -5 on both sides. We get r squared is equal to -40 divided by -5 is 8. We can finally square root both sides. Squares, square root cancels out. R equals, we can break this down, 2 times 4. 2 times 2. We have a pair under. This comes outside. And this is all review. Let me erase that there. So we have r equals 2 times the square root. The 8 broke down. The 4 broke down. The only thing that's left is that 2. So r equals 2 square root 2. And then number 5, this one looks like we got to squeeze this in there. First thing we got to do is subtract 3. Subtract 3. We're left with negative 4x squared equals negative 72. Got to subtract by negative, divide by negative 4, divide by negative 4. 72 negative 72 divided by negative 4 gives us 18. So moving this, let's move this up here. We have x squared equals 18. Now we got a square root. Cancel, cancel. The 18 can break down. That's 9 times 2. That's 3 times 3. 9 broke down, 18 broke down. So this comes out. And this finally gets to be x equals 3 times the square root of 2. See, that was number 5. Where's number 7? There's number 6. All right, number 6. Identify the y-intercepts of each. The x-intercepts of each. And to find that, we got to let y equal 0. So what we're going to do is we're going to plug in 0 for y. So 0 equals 2 times x plus 3 squared minus 8. Start off by adding 8 on both sides. We get 8 equals 2 times x plus 3 squared. Next, we want to divide by 2 on both sides. I'm just constantly simplifying. 8 divided by 2 is 4. So 4 equals, that cancels, x plus 3 squared. This part might be the trickier part of this concept, but this whole side is squared, so we're going to square root that whole side, which means we got to square root the whole left-hand side. So now the square root and the square, that still cancels out. And the square root of 4 we can simplify down. So I'm going to move this up here. So looking at the left-hand side, the square root of negative 4 is plus or minus 2 is equal to x plus 3. And finally, our last step, we got to subtract 3 on both sides. And we're left with negative 3 plus or minus 2 is equal to x. So we need to notice we have 2 solutions here. We have negative 3 plus 2 is equal to x. And I'll write this here. Additionally, we have negative 3 minus 2 is equal to x. So you can simplify both of these and get our answer. So we get that x equals negative 1. There's one of our answers. And x equals negative 5 for our other answer. Number 7, we got to solve the system by graphing. Hopefully you guys remember graphing linear functions from Math 1. This number on the outside here is your y-intercept. And this number here in front of the x is your rise over run. Okay, so if you don't remember it from Math 1, we've at least gone over it a few times in Math 2 so far. For further review. So let's graph this first line in purple. So our y-intercept is at 2. There's 2 right here. And our slope is down 1 over 1. Down 1 over 1. And I'm going to keep going all the way to the end just to we can keep going this way too. So it makes it more clear where our intersecting lines are. Now our second line here, we'll do this in blue. Our y-intercept is -2. And our rise is up 1 to the right 3. Up 1 to the right 1, 2, 3. And notice that right off the bat we got that point right there where they meet. Right, they intersected at this point here. That is going to be our solution there. And that is at 3, -1 looks like, for our solution of the system. All right, and to double check, you can go ahead and plug in 3 into both of these. So if you plug in 3 there, -3 plus 2 gives us -1. That's a check for the first. If we plug in 3 here, 3 divided by 3, oh, wrong place to plug in the 3. We got to plug it into here. 3 times 1 is 3, so that's 3 over 3. Here, let's do it off to the side. Y equals 1/3 times x minus 2. And for x, we're plugging in 3 here. So if we're looking at the two fractions, we multiply across. 3 times 1 is 3. On the bottom, 3 times 1 is 3, minus 2. This can be simplified. 3 divided by 3 is 1. I don't want to go over there, so this is 1 minus 2, which is -1. So they both check out either way. You get a check and a check. So that is your solution there. Number 8, our last one here, is solved by substitution. Notice that these are both y equals. So since they're both y equals, we can go ahead and take this 2x minus 5. Since it's equal to y, we can plug it into there. So if we rewrite this, this is 2x minus 5 is equal to x minus 4. We want to bring all our variables to one side. So subtract x, and you want to move all your numbers to the other side. So you can do this in one step, or you can do this in 2 separate steps. It's up to you. So when we simplify this out, 2x minus x gives us a positive x. -5, +5 cancel out. X minus x cancel out. And -4 plus 5 gives us 1. So once we have that 1, notice how it just says x equals 1. We got to plug that x back in to figure out what y equals. So we have y equals, for example, the first one, we have x minus 4. We're going to plug in 1 minus 4. So y equals -3. So our solution to this is actually 1, -3. So when we need to solve it, we need that coordinate there. And just to confirm, if we plug in 1 into here, do we get the same thing? 2 times 1 is 2, minus 5 is -3. That checks out.